Good morning, everyone. My name is Mansi Uniyal, and today our team is going to present on the topic of AI for automation for autonomous vehicles. Our team consists of Abhinav, Debdatta, Mansi, and Vaishnavi. So let's introduce as to what autonomous vehicles are. Autonomous vehicles are the ones which do not need any human interaction or direction to take decisions, and they understand whatever the environment is using the sensors and then make these real time decisions, which is all enabled by the AI technologies that is being developed every day. All this is done to improve the security, safety, and remove any human errors and regulate the traffic flow. And it's not just for the road, but even the vehicles that are there for the um, waterways and the airways. So let's have a brief introduction as to how is the evolution of the autonomous vehicles. So in 1500s we had the self-propelled car, from which we developed into the 1900s where we started having the cruise controls and the autopilot mode in the aircraft, to which now we have in 2000s the autopilot mode in the Teslas and the self-driving cars that we are aiming for. So let's look into what are the levels of a vehicle autonomy. So the autonomy has various levels, and all these are defined by the Society of Automotive Engineers (SAE), which defines these six driving automation, which ranges from zero, that is fully manual, to five, that is fully autonomous. And as the level rises, we can see that more of the technology plays a role for taking the decisions, and the automation is being inculcated in driving, and less of the human interaction is being needed. So this is a pictorial representation of the same, wherein initially in level 0, where we had no automation and all the driving tasks was being performed by the driver, to how we developed into a partial automation where some of the functions like the acceleration and the steering was done by the driver, was done by the automation. However, the others were done by the driver to take the decisions and monitor the environment, to what now we have as a high automation and the fully automation systems, which we aspire to have, where all the function is being done by the um, vehicle under all conditions, and the driver is only having opinion to control the same. So this is a brief overview as to what is the problem statement that we're aiming to work from.
Hello everyone, my name is Debdatta and today I am going to talk about how artificial intelligence can help in autonomous driving. First, we'll talk about sensor data processing. Autonomous vehicles rely on data from a lot of sensors, multiple cameras, lidar, radar, and sometimes even sonar. Dealing with the streams of data coming from this array of sensors is a huge and at the same time critical task. All of that data has to be turned into information in real time to be used to safely drive the car as if a perfect human driver was in control. On the road, human drivers need to be wary of their current surroundings, interact with others, and make decisions. Likewise, AV should perceive, interact, and make decisions. All of this is done by sensing information and processing it using deep neural networks and complicated machine learning algorithms. Next, we'll talk about path planning. Path planning is important in order to optimize the trajectory of the vehicle and to lead to better traffic patterns. This can help reduce delays and avoid congestion on the road. Planning is a very suitable task for artificial intelligence algorithms. It is a dynamic task that can take into consideration a lot of factors and solve optimization problem while executing the path. It smartly controls the system by taking into account the artificial environment near it and generates the feedback accordingly. Next, we'll talk about path execution. After the path is planned, the vehicle is able to navigate the road conditions by detecting objects, pedestrians, cycles, and traffic lights in order to reach the destination. The object detection algorithms are a primary focus of the AI community as they make it possible for human like behavior. The cameras need to be high resolution and represent the environment accurately. The intelligence in self driving cars enable them to perform tasks like image classification, object detection, segmentation, and localization. With various forms of data representation, the car can make predictions of the objects around it. A deep learning algorithm can model and help the car to prepare for all possible moves, which involve braking, halting, slowing down, changing lanes, and so on. So, the main objective is to interpret complex vision tasks, localize itself in the environment, enhance perception, and actuate kinematic maneuvers in self driving cars. This ensures road safety and easy commute as well. Next, we'll talk about driver monitoring, popularly known as the DMS system. The DMS core engine system analyzes the driver's behavior based on the image captured and detects if he or she is alert, drowsy, or distracted. The system is also equipped to detect the number of times the driver yawns or blinks or if he looks elsewhere. The main features of DMS are driver ID, distraction and drowsiness detection, activity detection, emotion recognition, and eyeball tracking. The DMS alerts the driver to ensure that he or she do not fall asleep or get distracted while driving. Now we'll talk about some recent breakthroughs which have happened in the field of automation. I'll start by describing Google's Waymo self-driving project. Waymo operates a commercial self-driving taxi service in Arizona. In October 2020, the company expanded the service to the public, and it was the only self-driving commercial service that operates without safety backup drivers in the vehicle at that time. The Waymo driver sees and understands the world through a number of sensors, including the cameras outside the car and powerful artificial intelligence software, a process they call as sense, solve, and go. Sensing is done using LiDAR, cameras, and radar as I had described earlier. The Waymo driver uses all that data to calculate a safe route with the help of AI and machine learning, allowing the car to respond in real time to the evolving traffic environment and continuously improve the performance. Once the Waymo driver has determined a path to take, the advanced motion control systems allow for smooth acceleration and braking in heavy traffic. Similarly, we have Qualcomm Snapdragon, which takes input from sensors and processes accordingly. Nvidia and Intel have also their versions of autonomous vehicles which focus primarily on safety and are continuously trying to improve their performance.
Hello everyone, my name is Abhinav Bohra and I would like to talk about how are autonomous vehicles trained. In order to train an AI model to drive a vehicle, we first enumerate the things a person does while driving a car. While driving, a person has to be aware of his surroundings like traffic, position of lanes, signs, as well as the characteristics of his or own vehicle like speed, steering angle, position, etc. Based on all these parameters, the person makes a sound decision on which action to take next. Similarly, our autonomous vehicles will take all the sensory data it can take from its surroundings, and based on those parameters, it takes the action that yields the most favorable outcome. While many machine learning techniques can be used to train vehicles this way, reinforcement learning is one of the most reliable and state of the art techniques used to train autonomous vehicles today. So, reinforcement learning is a machine learning technique designed to work on problems that can be modeled as Markov decision process. It involves an agent taking suitable action to maximize a predefined reward for the given environment. In layman terms, the agent is rewarded when it executes a favorable action and is punished when it executes unfavorable ones. For example, if we have to train a car to go down a straight road, we will increase the reward of the agent if it keep going straight, and it decrease it if it turns left or right. RL models take an input state and the current reward and then output the next action that our agent should take. These models can be designed with various algorithms. We will take a look at one of them, which is deep Q learning, for an example. Deep Q learning is combination of deep neural networks and Q learning. Q learning is a form of reinforcement learning which utilizes something known as Q values. These values are used to iteratively improve the behavior of agent undergoing training. The Q values indicate which actions is the best for the agent to take in this state. These Q values are stored in a Q table where the rows represent different state whereas the columns represent the different actions that the agent can take. At every state, the agent picks the action with highest Q value. These Q values are updated on the basis of the change in reward function. However, if we have a lot of states and a lot of choices for agent actions, then the Q table can become quite large, which can cause memory overflow and performance degradation. Hence, instead of keeping a table, we train a neural network to estimate Q values for all actions at a particular state. This is the core principle behind deep Q networks. That is, instead of updating Q values in a table, we update the weights of the neural network. Vehicle maneuvers in real life are incredibly complex and convoluted, which makes training model for all situations very difficult. Hence, a solution would be to train different simple maneuvers or policies using different models and then implement these models when the need arises. These sub-maneuvers can be trained by reinforcement learning algorithms like deep Q networks as discussed. While training, we can associate favorable actions with positive reward, whereas the unfavorable actions like collision with a negative reward. Thus, during training, favorable actions will accumulate higher Q values than the others, making sure that the vehicle takes the correct action at every possible state. We can train a model to execute simple maneuvers like going straight, turning left, turning right, or exiting a roundabout. These sub policies can then be combined to form a fully functioning self driving car, which can execute the trained maneuvers. So, when a car approaches a right turn, it knows that it has to execute the trained right turn subroutine, or when it's on a straight road, it has to execute the straight turn policy, and so on.
Hello, I'm Vaishnavi Malwade. I will be talking about the pros of autonomous vehicles. The first pro is prevention of car crashes. In 2017, 94% of the car crashes were caused due to human error. Majority of these causes were due to drunk driving or distracted driving. Multitasking by the driver led to negatively impacting the driving performance and thus leading to car accidents. Sophisticated systems and algorithms used to drive autonomous vehicles will essentially eliminate the cost of human error. It is estimated that self-driving cars can reduce up to 90% of the accidents. Traffic efficiency. One of the major benefits of self-driving cars is their ability to communicate with each other. This ability in real time will give us optimal distances and also optimal paths with minimum traffic. Thus, autonomous vehicles will help us pick the best route to be followed to reach our destination. The human driven cars cannot do this. They cannot anticipate traffic jams and calculate their movements. Self driving cars have a faster reaction time than regular cars. Potential danger will be minimized by software and sensors. This is an example of efficient traffic management by autonomous vehicles. The next pro of autonomous vehicles is better access. Autonomous vehicles can be a great choice for people who cannot or choose not to drive. They can also be a great alternative for people with disability or the elderly population. Thus, self-driving cars will give a safe and reliable mode of transportation. Environmental friendliness. The environment is another important factor in self-driving car debate. Consistent speeds that self-driving cars travel at will decrease braking and acceleration. We will also use internal combustion engines in these cars. All these factors will contribute to reducing and making the environment more sustainable. This will result in less fuel usage, less population, and cleaner air. Thus, self-driving cars are a more environmentally sustainable and friendly option. Let us talk about the obstacles in autonomous vehicles. The first obstacle is security issues. Hacking is one of the possible causes of self-driving cars. Automated cars must share the network protocol in order to communicate and coordinate with one another. Hacking could occur in lots of cars and which are connected to the same network are probable to cause them a serious damage to busy roads. Even a minor hack can adversely affect the traffic. Job losses. People who are dependent on driving for their livelihood may lose their jobs with the advent of self-driving vehicles. All those in the taxi and trucking industries as well as the bus drivers will need to seek new jobs. Automated cars will also replace Uber and fast food delivery. The next obstacle is initial cost. The initial investment for bringing autonomous vehicles is very high. We expect as the technology matures, this cost will come down. Machine error. Autonomous vehicles are driven by softwares and algorithms. There is a probability that these algorithms may glitch. Thus, they may put the riders at more danger than they were previously when they were driven by humans. The future of autonomous vehicles. As we are progressing in a world driven by AI, we are designing more efficient and accurate algorithms. Many companies and academic institutions are doing research in the field of autonomous vehicles and electric cars. We are also developing new chips which are computationally efficient and more powerful. Thus, we can say that the advantages of autonomous vehicles outweigh the cons. We expect that in the future the private ownership of autonomous vehicles may prevail. There may be a transition period which is observed in similar other technologies like computers, mobile phones, conventional vehicles, etc. Thus, as technology progresses, we expect the cost of autonomous vehicles to go down and make autonomous vehicles a safer and reliable option for our population. This brings us to the end of our presentation. Thank you.